Hey guys, Mrs. Dan's here. So we are on alternate lesson 2, which is page 13 in your workbook. If you can just write down the objective on the lines. We will graph absolute value functions and discover the parts of the equation that cause the graph to shift. And it could shift up, down, right, or left. If I was in class today, I would actually have you do the do now on your own, but I might as well do it with you. But something that you must do on your own is check your homework answers from yesterday. They are posted in Google Classroom. So in the do now, the first table is filled in for you and already graphed for you. We need to fill in the other table. Remember, you can use your graphing calculator, or you can kind of just use your common sense. Take a look for G. We have to do the absolute value of -3, which is just 3, and then add on 2, which means we should get an answer of 5, right? So we're actually using all of the results from this table. All of this already does the absolute value of x for us. The function g is now just adding on 2. So the absolute value of -2 is 2. When we add on 2, we get 4. Absolute value of -1, add on 2, the answer is 3. Absolute value of 0, add on 2, gives us a 2. Absolute value of 1, add on 2. Absolute value of 2, add on 2. And the absolute value of 3, add on 2. So now I have points to plot, right? I plot the x coordinate and the y coordinate. So if you can go and plot all of these points on the graph. Now you need to remember that this table would go on forever, which means this function is going forever upward in both the right direction and the left direction, because we learned yesterday that absolute value functions always make a V. If you get something other than a V, you made a mistake. This point here, the turning point or the vertex, is very important because it shows us where the point of our V is. Take a look at function h. We're still doing the absolute value of x, but now we're subtracting 3. I'm just going to change my color here. So absolute value of -3 is 3. Take away 3, I get a 0. Absolute value of -2 is 2. Take away 3, I get a -1. And the absolute value of -1 minus 3. Absolute value of 0 minus 3. Absolute value of 1 minus 3. Absolute value of 2 minus 3. And the absolute value of 3 minus 3. And we plot those points. Again, this goes on forever. The V opens upward. It's hard for me to draw my lines with this special pen that I'm using, but I could see the pattern of the points. It's going up 1 over 1. So I'm making sure that my line passes through the correct points. Something I didn't do was label my function g. This is function h, and I'm going to go back and label function g. And what's nice about this function notation is I just have to write the name of the function and not the whole expression here. So let's answer this. Describe the change that occurred from the graph of function f to the graph of function g. So function f is what was already graphed for us. It's in black here. And function g is my blue graph. So describe what happened from function f to function g. Well, it looks like it just shifted up 2 units to me. I have to tell you, I'm noticing function f right now, and it's kind of graphed a little off. I don't know what happened. I don't know if it's like that in your book or if it's just like that on my paper, but it's like not perfect. It should be going through. Like right here, 0, 0, right? This side is a little off. So maybe you should fix that in your book. So if I look at the vertex of function f and the vertex of function g, it is up 2 units. And it's not just the vertex that's up 2 units, it's the entire graph that's up 2 units. Every point is increased by 2. I'm going to say that the change that occurred is that function g is shifted 2 units above function f. G of x is 2 units above function f. And then describe the change that occurred from function f to function h. Well, function h now looks like it's 1, 2, 3 units below. It's shifted 3 units below function f. I'm going to use the word down. H of x is shifted 3 units down from f of x. So what we're trying to notice here actually is that these shifts occurred, but I can actually see those shifts in my equation. You see what f of x was. It's just the absolute value of x. G of x was function f, right? This x, absolute value of x is function f. It just has a plus 2 at the end. This plus 2 makes it shift up 2 units. And you can see that function h really is function f again, right? The absolute value of x really was what we wrote for function f. And now it has this minus 3, so this minus 3 makes it shift down 3 units. So it turns out that a plus makes it go up and a minus makes it go down. So let's answer this. So when we compare the absolute value parent function, we like to call it the parent function because it's what we compare everything to, f of x, which is the absolute value of x, to a function in this form where something is added on at the end. We notice that k shifts the parent function either up or down. And if we added a positive number outside those absolute value signs, then it shifted up. And if we added a negative number outside the absolute value signs, it shifted down. So now we're ready to do the next part. Here's function f again. This time it's graphed correctly on our graph. And now they're defining function g a little bit differently. Notice we have this minus 2, but inside the absolute value function. So now we have to be careful. We have to do the absolute value of negative 3 minus 2. So I do the negative 3 minus 2 first, and negative 3 minus 2 is a negative 5. And that negative 5 is in absolute value symbols. So what's the absolute value of negative 5? It's a positive 5. So it's not like I'm doing anything to this x value like I did in the first this y value, I'm sorry. I'm not doing anything to that y value like I did in the first problem, and that's because this is inside the absolute value functions. So it's more having an effect on x instead of having an effect on y. So do the problem. Do absolute value of negative 2 minus 2, which is the absolute value of negative 4, which turns out to be 4. And then the absolute value of negative 1 minus 2 is equal to the absolute value of negative 3, which turns out to be 3. I actually have an idea. I want you to go to your graphing calculator. Let me open up mine. And I just want to make sure that you know how to enter this properly. So if we go to our y equals, clear out anything you have there. We learned yesterday where the absolute value symbols are. Remember, it's in math. Move over to num. And the very first thing, ABS, stands for absolute value. So I want to type in x minus 2, and I want to look at my screen just to make sure all of that is in between the absolute value signs. Now if I go to my table of values, I could actually just copy the information from my calculator onto my paper. So I could see my 5, 4, 3, this is 2, 1, and 0, and then 1. So look at where the symmetry is happening. It starts right here, which means this is my vertex. And I can just plot those points now. So take a look. Remember we said that absolute value must always be a V-like shape and that the most important thing is a vertex. So I do have the vertex and I know that it should be symmetrical. So I could see these 2 points here matching up. I can find more points on the right side of this just by using the left side to guide me, right? It continues symmetrically. So make sure you do continue the points, continue the line and put arrows. And we can see that this graph that I just did in orange actually didn't shift up or down now. It shifted to the right. So the statement that I made before, that you have to do this work inside the absolute value symbols, is important because it kind of affects the x instead of the y, right? I made that comment before. And I could see that it must be affecting the x because it shifted to the right, which means it followed the x-axis. Where if we look back at our do now, this shifted up or down, which means it affected the y value, right? So an up-down motion affects the y value. So when I have something outside the absolute value signs, it's really affecting the y's. And if I have something inside the absolute value sign, it's going to affect the x's. Let's fill in the table for h of x. I'm just going to use my calculator. Again, in math, over to num, ABS, and x plus 1. And go look at your table and copy the information. And plot your points. Remember, we should be able to find symmetry in our table, which means we found our vertex. And that's where the V changes direction. Make sure you extend to the edges. Make sure you don't just randomly extend this line. You can see how carefully I'm trying to draw mine so that it goes through each point precisely. And this is called h of x. So again, it's shifted sideways. So g of x shifted to the right and h of x shifted to the left. G of x shifted right 2 units. And now some of you might be thinking that's pretty strange. Do you see inside the absolute value signs, it's a -2, but it happened to shift to the right too. So when it affects the x value, it kind of has like a strange result. We would maybe think that it should shift left, but it doesn't. It shifts right. So that's just something we really have to focus on when we're affecting the x value, meaning that there's some number added on inside the absolute value symbols. It seems to kind of shift in the opposite direction than we would expect. We could see by filling in the tables which way it definitely shifts. So this is true. We just have to, like if we want to graph quickly, we have to remember which way it shifts. If I don't want to graph quickly, if I want to always use my calculator and fill in a table, then as long as I enter it into my calculator correctly, I'll get the right points to plot. But I'm hoping that we're going to see that we can graph very quickly now. We might not have to fill in a table of values anymore if we understand which way the function will shift. So if we write down what happened to h of x, since there's a +1 in here, it shifted 1 unit, but remember, it's a little strange, it shifted 1 unit to the left. So let's go see how we can quickly graph then, after we fill in these notes. So when we have the parent function being compared to a function that we do something inside the absolute value symbols, we notice that the number, that h, will shift the parent function either right or left. And we have to be careful that when we add a positive number inside the absolute value signs, it actually shifts left. And when we add a negative number inside the absolute value signs, it actually shifts right. So here's how we can do it quickly. This shows a shift to the left, because it's inside the absolute value symbols, kind of shifts the opposite way that we would think, left 2. And then this shows down 3. When it's on the outside, it shifts the way we would expect, either up or down, but when we add something inside, it shifts right or left, kind of a little strangely. So this will shift the parent function 2 units left and 3 units down. So we can just use those numbers to even tell us where the vertex is. 2 units to the left would be a -2, and 3 units, I'm lying to you. No, I'm not lying to you. 2 units to the left would be a -2, and 3 units down would be a -3. So from the origin, 2 to the left, 3 down. Here's my new vertex. And since the coefficient of x is just a 1, it's going to go up 1 over 1 on both sides. and this is f of x. So let's try again. Let's make sure we've got this. This shifts to the correct, right? And this will shift correct up. I'm hoping you answered my questions. So to the right one is a positive 1. Up 2 is a positive 2. You could always think about starting at the origin and just doing the shift to the 1 to the right, 2 up. Here's my vertex, and up 1 over 1 from the vertex gives me the V-like shape. See how quick that is? Now, if ever you're getting stuck, pull out the calculator and put it in your table and graph it. Quick little notes. This will shift right or left, depending on what sign the H is. And this will shift up or down depending on what sign the K is. So that means that the vertex really is at HK. Your homework is to graph using your shifts. You could always double check yourself on your calculator. So remember, this shifts right, and this shifts down, right 2, down 4. That number I just wrote is that point I just wrote is your vertex. And go up 1 over 1 on each side. Okay, I'm done. Have a good day. Finish your homework, and hopefully I see you tomorrow. Okay, see you, bye.